For assignment statements, we have three forms. First is single assignment, and so far that is the form of assignment that we've been using. The syntax is identifier or any variable followed by the assignment operator and then expression which is to be evaluated and a semicolon at the end to terminate the statement. Examples to this are like this one, y gets the value of x plus 5. So whatever is the value of x, say for example, x is 3. 3 plus 5 is, that's 8. So that value 8 is assigned to variable y. And also, the one that we've discussed before, computing the area of a circle, we say in the formula 3.14 times r, the radius, times r, the radius. So this is our expression on this right side, right? And the assignment operator is this one, and the variable on the left side will get the value of this expression. So if, for example, r is 2, the radius is 2, and this is 2. 2 times 2 is 4 times 3.14. The right side value is 12 point something, or maybe 5, 6. And so variable area will have a value 12.56. So again, the right side expression is evaluated first, and whatever is the value of this, it will be assigned to the identifier or to the variable. So that is single assignment statement. The second is multiple assignment. In this assignment statement, there are several variables, like we have here variable or identifier 1, we have 2, variable 2, we have variable, say we have variable n or n variables. And n, of course, must be a finite value. And then this is the expression like in here that will be evaluated. And how is this executed? The assignment is done from right going left. So first, this is evaluated. Whatever is the value of this expression, it will be assigned to the rightmost variable, and then next it will be assigned to the next variable going to the left side. Okay, so again, the assignment proceeds from right going left. When are you going to use multiple assignment statement? You are going to use that when there are several variables with the same value, which is this expression. So for example, we have here x, variable x is the same as variable y, which is set to that. So when this is executed by the computer, the value 3.45 will be assigned first to y. So first, y is set to 3.45. After that, it would set the value 3.45 to x. And then later, x becomes 3.45. So again, take note, y first is assigned and then next is x. So from right going left. Another example we have here is this one. When you have three variables x, y, z with the common value 0. So instead of you saying in your program z is equal to 0 and then y is equal to 0 and x is equal to 0, you would instead use one multiple assignment statement. This one here is preferable compared to having 3 lines. So this is preferable, the one line multiple assignment statement. So the first to be assigned is z because it is from right going to the left. So it is z that is set to 0 first, second, y is set to 0, and lastly, x is set to 0. Another one here is 4 variables a, b, c, d are all set to the same value 1. So first, 1 is assigned to this, the value 1, and next it is assigned to c. So c is the next variable to be assigned with the value 1. And next, assign 1 to b, and lastly, assign 1 to a. So that's the flow of the execution. So again, you use multiple assignment statement when there are several variables having the same or a common value. The third form is this one, which we call as shorthand assignment statement. This shorthand assignment statement makes use of compound operators. We call this compound operator. Examples of compound operators are here. This one, the plus equals, minus equals, times equals, divide equals, and the percent equals. These are some examples of compound operators. Compound operators like this one, plus equals, it consists of two symbols, the addition and then the assignment operator, and there must be no space in between. They are side by side, no space in between. They are adjacent to each other. And when we say x plus equals y, that is equivalent to saying x gets x plus y. So notice that we can write this into shorthand assignment statement. On the left side is our shorthand assignment statement. And when can you rewrite a statement like this into shorthand assignment statement like this one? It is when the variable on the left side of the assignment operator appears on the right side, this expression here, as one of the operands of the last to be performed operator. Now, in this expression, there is only one operator, the plus, and so this is both the first and the last operator to be executed. Now, x appears here, and so you can rewrite it this way. And also here, x appears here, so you can rewrite it this way. Okay, and so on. So if we have this, x gets x plus y times z, can we rewrite this into shorthand assignment statement? Take note that in the right side expression, there are now two operators to be performed, addition and multiplication. Which of these two is performed first? It would be the multiplication. So the last to be performed operator is the addition. And so x here is, take note, it is an operand of the last to be performed. So we can rewrite it this way. The operator is plus, so you could say x plus equals, that's the compound operator, and then the expression here is y times z. So that is written as x plus equals y times z. That is the compound operator. And you can rewrite it, this is form 3, shorthand assignment statement, while this one is form 1, the single assignment. So if we have here x gets x plus 2, you can rewrite it in shorthand assignment statement as x plus equals 2. This is of the form single assignment statement, number 1. Okay, this one here. While this is number 3, the shorthand. When we have I gets I plus 1, you could rewrite it in a shorthand assignment statement form I plus equals 1. And so, if we have this, take note that is our compound operator. So the expression is this one, right? That's negative 2 times this one. And x is one of the operator of the last to be performed multiplication, this one here. Now we need to put parentheses there because if we remove the parentheses, what will happen? X times negative 2 is performed first because this is multiplication and that is multiplication, the same priority, and the one that will be executed first without the parentheses is of course the first multiplication, which is x times negative 2, which is not equivalent to the shorthand assignment statement. Okay, so there must be a parenthesis there because this is one expression which is multiplied by the variable x. The conditional operator, which consists of two symbols, the question mark and colon, is equivalent to the if-else statement in terms of execution flow. The syntax to how to use this operator is this one. In here, you have three expressions. First part is the Boolean expression, followed by the question mark symbol, another expression, and then the colon, and the third expression. The Boolean expression is a condition that has a true or false value. Boolean is actually a data type with two values only, and these two values are the true and the false. And this part here expression 2 and expression 3. So our first example here is this statement. Say if this is how we use it, j gets I less than 0, question mark, 0, colon, 100. So this is now the whole thing here is an assignment statement. We have here variable j and assignment operator. And the first thing that needs to be done is to evaluate the value of that right side of the assignment statement. And whatever is the value of that, it will be assigned to variable j. So how do we evaluate this? So again, this part here is the Boolean expression. This is the Boolean expression or the condition. If I is equal to 5, this would be 5 less than 0. That is evaluated to false, right? 5 less than 0 is false. And so since that is false, the value of the whole expression is this part here. If it is true, this is the value. Okay. So again, the semantic or the execution flow of this expression here is first you evaluate the condition. If it is true, then this expression is evaluated and this one is not. If it is false, Boolean expression or the condition, this expression too is not evaluated. What is evaluated is the expression 3. So that is why it says here that the execution of the conditional operator is similar to the if-else statement. So back here, if since I is 5 less and the condition says 5 less than 0 is false, then 100 is the value of the whole expression, okay? And that is the one being assigned to j. So the value of j is 100. For the second example, we have here f less than g returns. If it's true, returns f. If it's not true, then evaluate g. And the whole value of this expression here is whatever is evaluated. If it is true, then f is the value of the whole expression. If this condition is false, then g is the value of the whole expression. So in this case, if f is 2 and g is 3, then f less than g, question mark, f colon g, this is f is 2 and say less than g is 3. 2 less than 3 is true, right? So this is evaluated, f is 2, so the whole expression here is equal to 2. And if this is an assignment statement, assigning this, say for example, to h, then variable h will have a value 2 because the value of the right side of the assignment statement is 2, which is this one, f, and that is assigned to h. For the third example, we have here a shorthand assignment statement. From our previous lesson, this is equivalent to saying, okay, that's a compound operator. The plus equal is a compound operator, which is when this is rewritten in normal assignment statement or single assignment statement, it is equivalent to this. Okay, so that is C gets C plus because that is plus, and the right side value is this one here. So say if A is 5 and B is 3 and C is 2, then what is the output if this printf is executed? Okay, let's trace it. So we need to evaluate first or determine the value of this part here, which is in this form using the conditional operator. So this one here is A is 5, so this would be 5 greater, that is 0. Then, and A is 5 less than or equal to 10. So 5 greater 0 is true, and 5 less than or equal to 10 is true. True and true, that would result to true. So the whole condition here, this part here, is true. Since that is true, this is the one which is evaluated next, and this one is ignored. So what is A++? Take note that in this statement line, there are several operators, right? We have assignment operator, we have addition, we have greater, we have and, logical and, we have less than or equal, we have this question mark, colon, the conditional operator here, and we have the post increment and the division. So this one here, which is post increment, being post increment, this is executed last, right, from our previous lesson. And so that means that all of the other operators are executed before the increment. So since the condition here is true, this one here, the result here, this is evaluated, but this operator is not executed yet. So the value of this part here is what? The value of this one is the original value of A, which is 5. And that is the value of the whole conditional expression here, 5. After that, our initial value for C is 2. So we execute addition, that is 2 plus 5. So the whole right side is 7. And it will be assigned to C. So your C now is equal to 7 and your B is as is, no change. And after executing all the operators in this statement, we execute the post increment. And so A, which is 5, becomes 6 and C is 7. The output for the printf would now be A is equal to, it is 6, comma, okay, because you have a comma there, B is equal to, B is not changed, it is 3, and C is equal to 7, which is this value. So this is the output of the printf statement. However, if instead of post increment, say we replace this with pre-increment. So say we replace that with plus plus A. This time it is pre-increment. And so since that is pre, we are going to perform this first. So your A, which is initially 5, at this point your A becomes 6. And then all the rest are executed. So again, this is true. So since that is true, this is the value of the whole expression here. And that is equal to A is 5, increment it. So this becomes 6. And plus C is initially 2. So the right side of the assignment statement is 2 plus 6, which is equal to 8, and that is assigned to C, this one here. So C at this point is not 7, but 8, and A is 6. So the output of the printf would now be what? A is equal to 6, comma, B is not changed, so it is 3, and C is equal to 8. Okay, this is the output of the printf if we use the pre-increment. And this is the output of the printf if we use the post increment for the variable A, and this is plus plus A in here, pre-increment for A. Okay, so you see the difference. In here, C is 7, and in here, C is 8. The reason for that is, in here, the increment is performed last, so C is not 8. While in here, the increment is performed first, so this is 8. Now, in case of different data types found in the expression or in the statement, the resulting value of that expression has a data type which is the one with the highest precision among all of the data types found in the expression. Example, if we have, say we declare type float x and type double y, and then we say x plus y, what is the data type of the result? X is float, and Y is type double. So we have float operator double. The data type of the result is type double, the one with the highest precision. What do we mean by precision? It's referring to memory allocation. So the one with the largest memory allocation. That is what we mean by saying highest precision. The value or the variable with the highest precision, or the data type with the highest precision. It's referring to the one with the largest memory allocation. So recall that float type is 4 bytes memory allocation and double is 8 bytes. And so it is double who has the highest precision or the highest or largest memory allocation. So that is why the resulting value when this is evaluated is type double. So that is the rule for data type conversion. Now, if one operand is float or double or long double, and then we have here an operator and int or character, integer or character type is the second operand. What is the data type of the resulting value? Long double is of course larger than double, and of course int and character are less in memory allocation compared to long double. So the data type of the resulting value would be long double. Say if we have here printf, okay, the question now is what should be the conversion specification which tells the data type of the resulting value of the expression c plus 7. Now the expression is C plus 7. C is type character and 7 is type integer. Which of these two data type has the highest precision or the larger memory allocation? It is integer, right? Because character is 1 byte, memory allocation integer is 2 bytes or 16 bits. So it is 7. So the value of the result of this one is type integer. And what is that? Now, you might be wondering, can we add two operands of different data types? This one is symbol, C, and this is 7. Now, in C programming language, there is automatic conversion from character symbol to integer and integer to character symbol, okay? You can automatically convert that symbol to integer and integer to symbol because we have the ASCII table. ASCII stands for American Standard Code for Information, and the last I is interchange. ASCII is an acronym that stands for American Standard Code for Information Interchange. And this ASCII table is just a list of symbols and its corresponding numeric value, particularly integer value. Say for example, for symbol uppercase A, the integer value equivalent of symbol uppercase or capital A is 65. And the next uppercase B is 66. The next uppercase C or capital C is 67, and so on. And for small letters, say small a, the integer equivalent value for small a is 97, and small b or lowercase b is 98, and so on. So all you have to do is to memorize this one and this one. You will know the integer value of the rest of the letters, whether uppercase or capital letters or small letters or lowercase letters. So since this is numeric addition, what will be used in behalf of this symbol C is the numeric or the integer value of C, which is, what is small c? It is 99, right? Because this is small a is 97, small b is 98, small c therefore is 99. So this would be 99 plus 7. So the value here is type integer, which is what is the value of this. 9 plus 7 is 16, carry 1. So that's 106, right? So 106 is this one, the value of this expression. And take note, it is type integer. So the question mark here is replaced by what conversion specification? It would be integer is %d, right? And so the output when this is executed is 106 integer type value. If we have printf statement, printf, and then instead of d, we have %c, and then, so it is character type or symbol, and then the expression is c plus 7. So instead of a while ago, this is %d, that's why it displays an integer value 106. If we change this one to %c, what will be the output? It should be a symbol, right? Not an integer value. So since c is 99, this is 99 plus 7, the value of this is 106. But you say here to display the character or the character symbol. So the output would not be 106, but the output is the symbol corresponding to or having an equivalent integer value of 106 in the ASCII table. And what is that symbol whose integer value is 106? Somewhere here. C is 99. If C is 99, what is the symbol corresponding to integer 106? It would be small letter J, right? So the output here would be small letter J. So when you use the %C conversion specification here, you're telling the computer to display the symbol, and that is letter J, whose numeric or integer value is 106. But if you change this to D, it would display not the symbol, but it would display the integer value 106. Now, say for example, for type conversion using a cast, we call this one here a cast. Say for example, if we declare x to be float and y to be integer, and then say y gets x plus 23, and say x is equal to, say we set an initial value to x, and that would be, say, 12.7. So what is this equal to? It is 12.7, the value of x, plus 23. So this is float type plus integer type. What is the data type of the result? It is, of course, float, the one with the highest precision. And so, what is that exact value? 12.7 plus 23, that is 35.7. So, this is y gets 35.7. But take note that y is type integer. This is type integer, but this value is type float. In C programming language, depending on the C compiler, this is usually truncated. So the actual value of y will just be 35 instead of 35.7. So there is data loss. The 0.7 is data loss. So you have to be careful that when you assign, if the right side of the assignment statement is like a big container, say this is the container for float type, and say this is integer on the left side, like this one, y is integer, it's like you are putting the content of a large container into a small container, which if you are going to put all the content in here into this small container, what will happen? Some of the content here will be lost. Okay, so we call that data loss. And what is the data loss here? It is 0.7, okay, because it is type integer, the variable y, and so it could accept only in the integer part, which is 35. And so the 0.7 is the data loss. In programming, this is not a good practice that you have data loss. One way to convert this right side into integer is to put a cast. So you could write it this way: y gets int, and then you have x plus 23. Okay, so if that is written that way, the whole value of this, which is 35.7, will be converted to integer type because we have there a cast. So the expression on the right side will become 35 first before it is assigned to y. If this is y gets int, the cast, and then you have your x plus 23. There are no parentheses, for example, this one. The one that will be converted to integer is just x, not the x plus 23. So the value of x, which is 12.7, will be converted to integer. So this will become 12, and then plus 23, that will become 35. And 35 is integer. It is valid to assign it to variable y, which is integer type. There is no data type mismatch. So this is one way of converting from one data type to another by putting this cast in front of the expression whose data type you want to be changed into this data type.